Hi everyone, I welcome you to the presentation of this lecture on mesh analysis. So a mesh is basically a loop which does not contain any other loops within it. And then we're going to look at steps to find mesh currents. So number one, we'll assign mesh currents to the number of meshes. Then we'll apply Kirchhoff's voltage law to each of the number of meshes. Then we'll use Ohm's law to express voltages in terms of the meshes. We're going to result with simultaneous equations. We solve them and then we're going to have mesh currents. So as an example, for the circuit in the given figure below, find the branch currents I1, I2 and I3 using mesh current. So that's the circuit. In that circuit we have a voltage source and the voltage source in that one. So we've got two meshes. We've got a mesh there and a mesh there. They want us to find these branch currents I1, I2 and I3. So let's begin. Okay, so on our solutions we have the circuit which is that one there. So from the given circuit you identify the two meshes. So we've got a mesh in that loop. So you'll be getting branches as you move in the anti-clockwise direction. So the ones which have polarities already, like this one, you take them the way they are, and this one, these don't have polarities, you assign them, but you sign them in such a way that the sign you meet first, you give it a positive. So as you can see that 5 is, we can move there, you give it a positive, and the other one automatically will be negative. If you look at the 10 there, you find that one first, so you give that one positive and the other one will be negative there. Then we can formulate an equation from there. So the equation will be negative 15 because you're meeting this 15 from the negative. The 5 is positive, that's why you have 5i. The 10, the I is meeting from the positive, so you have 10i1. The other one here is meeting from the negative, that's why it's negative i2. Then plus 10, which is that one. That's the equation. When you simplify that equation, you're going to have the following. Okay. So when you simplify that equation, you're going to have that. Open the brackets, you have that. This, for simplifying, you're going to have that as our first equation in the first loop. So you go to our second loop there. So in the second loop, you assign polarities as well, which are those that you are moving. So this one is positive, that one negative, positive, negative, positive, negative. Then you'll be getting these as you are moving in the clockwise direction. So when you meet this one to be negative 10, which is that one, when you meet this branch, you're entering from the positive, so it will be positive 10. And then this current now will enter from the negative there, that's why you have negative I1. Then you have the 6, which is that one, and the 4, which is that one there. When you simplify that equation, you're going to have that final equation as our equation in the loop number 2. Then you solve these two simultaneously, this one and this one. You're going to have the following. So we have I1 as 1 amp. And then if you substitute that into the other equation, you're going to have I2 as 1 amp as well. Therefore, for the branch currents, you can see this I1 is basically the loop current in mesh number 1. So you have that one, I1 is basically that. I2 is also, this I2 is a loop current in loop number 2, which is that one there. And then if you do Kirchhoff's current law, you realize that the current leaving is equal to the current entering. So I3 will basically be I2 minus I1, which is the difference between the two 1 amps, and you're going to have I3 as 0 amps. So this marks the end of my presentation on mesh analysis. The next presentation I'm going to do super mesh. Thanks for watching.